There are various ways to repair SMPS circuits board. In this video, I will show you the one of easy ways to do it, by using the SKQ module. Step by step in the details. This is a switch mode power supply, or SMPS for short, electrical damaged, which parts damaged have been taken off around here. On the back of the circuits board, short circuit burnt can be seen over here. That was the reason I took parts off and cleaned area. These parts are EMI and rectifier components. They are all right now. The parts on the right side are the circuit's output components, and okay, they have been tested. 2 rectifier diodes have been replaced here. A fuse has been replaced as well. This is the original MOSFET with its bracket together, it located here before. The MOSFET was broken by short circuit. The broken IC chip, which located here before. The others such as potentiometer, inductor, resistors, diodes and capacitors etc. they were all located around here. Incidentally, the most of those loosened, small parts in their size were workable. The circle mark was this capacitor original located, however it has been moved to here. The bare wire on the back is the capacitor's negative, or the hot ground, the green wire is positive. The reason moved it to there is to make a clear enough room around here. That clear room is for this device, which is called SKQ module, to be put there, in this way. The SKQ module with its 4 various color wires attached. There are DIY snub circuits parts tied on its back side. 2 of these wires are from the snub circuit, which the wire in red color is from the anode end of the diode. That is a DIY made bracket, which bolted on a MOSFET from the SKQ module. By using the SKQ module, it is much simpler and easier than replacing the individual part of faulty one by one. The module has been fixed and secured on the back heatsink plate here by 2 small bolts and nuts. Also the wires necessary connected. Those are a pair of the output DC wires. This is the circuit's diagram, which showed the related details connection. However, it is not the every part or component on the circuit's board showed. This area from the diagram is the parts or components here on the board. That area from the diagram is the parts or components there on the board. This is the SKQ module, which been fixed on the heatsink on the rear of the circuit's board. The parts here have the details been written on the diagram as whole, is the snub circuit, which is DIY made. Those parts from right hand on the diagram, also have details been written on, are the added functions such as a LED indicator and a load resistor. As already indicated previously, the snub circuit's components tied on the back of the SKQ module. The LED indicator and load resistor are located here. They can be seen, a LED is here. A load resistor is soldered on the circuit's board. The black wire from the SKQ module is connected to the hot ground on the circuit's board. Just over here on the back. The red wire from the module is connected to the transformer's number 2 pin, which used to connect the MOSFET's drain pin. It is over here with the red in color. The yellow wire from the module is connected to the output of DC positive. It is the yellow wire with the black heat shrink on the back of the circuits board. The blue wire from the module is connected to the output of DC negative, or ground. It is the one here on the back of the circuits board. This is the anode side of the diode on the snub circuit, and its wire is red in color, which is to be jointed with the red wire from the module on the back of the circuits board, just here. The snub circuit's other end of the wire is the orange in color, which is connected to the high voltage capacitor's positive, right over here on the back of the circuits board. Have a good look at the things between the snub circuit's parts and heatsink. There are an insulation pad and candle-like thing glued together to protect against the high voltage short. The heat generated from the MOSFET can be exhausted through DIY-made bracket and heatsink. There is plenty of room for heat exhausting as well. This is the AC input, which will be a socket connected here. That is a pair of the output DC wires. The repairs and upgraded have been done, and whole thing is ready. A socket for the AC input. A pair of wires for the DC output. A 2 amperes fuse replacement has been done. The DC output will be adjusted to just over 14 volt. A DC voltage and ampere meter has been connected to the output with a load. AC input has been plugged into the AC power, and the green LED is on. Also, a car's bulb as a load has been set up but not connected through yet. Turning on the meter. Then switch the AC power on. Incidentally, the AC power was off a moment ago. The meter has indicated 12.1 volt. To adjust the output voltage above 14 volt, 14.2 and 14.3 volt. Stay here now. Connecting through a bulb now. The meter's indication has changed. All good. Thank you for watching. Please like, share, comment, and subscribe if you have enjoyed the video. Your encouragement is my motivation.